Welcome back to Recruiter.com. In this next video on financial formulas, we're going to be going over the depreciation and amortization formulas. Let's get started. So I've set up this template right here, and as you can see, we're going to be going through 4 different types of depreciation. The straight line method, the sum of years digits, declining balance, and the double declining balance. And we're going to see how Excel interprets these formulas. Then I've put over here the asset that we're going to be testing. And right now we have a machine that cost us $375,000. We've decided that the useful life is 5 years and our salvage value at the end of the 5 years will be $75,000. Okay, so now let's get started writing out these formulas. Let's go through the longhand method of writing out the formula. So with the straight line method, we'll take a look at the formula, how you'd have to do it on paper and pencil, and then we'll come back and we'll use the SLN formula that Excel has built in for us, just so that we can verify how Excel is calculating these formulas. So let's start with the straight line method over here. And if you remember back from your accounting days, it is the cost less the salvage value and then divided by the useful life in years. So it's a really basic formula, and we can simply go ahead and manually calculate this just by grabbing these inputs. So the cost less the salvage divided by the useful life in years. And you can see it quickly returns $60,000, and this is the amount of depreciation expense for each year for the next 5 years. And so we've also calculated this same amount using the SLN formula that Excel has built in. And if we take a look at this, you can see that the arguments are exactly the same as what we had calculated up here. So the cost minus the salvage in the year, and Excel needs to know the cost, the salvage value, and the life of the asset. So I think this formula makes sense. So let's go ahead and move on to this sum of years digits. And for this one too, let's just go ahead and write it out here as well. Now the name of this formula actually kind of gives it away. So it's the sum of the years. So literally year 1, year 2, 3, 4, and 5. And I'm going to use Alt and equals to go ahead and auto sum that. So we're taking chunks of each year. So the first year we're actually going to depreciate 5/15ths. And then the next year 4/15ths. So if we graph this, we can quickly do this just by inserting a pie chart and showing it in a better format, in a better view here. You can see that the largest chunk will get depreciated the first year, then it'll slowly get smaller and smaller slivers towards the very end. Let's go ahead and get rid of this, and let's calculate how much the first year would be. So I'm going to take the cost less the salvage value and then multiply that against 5/15ths to therefore getting $100,000 worth of depreciation in the first year. And just as we'd expect, Excel's formula for the SYD formula has calculated the exact same thing, $100,000 in the first year. So if we take a peek at this formula, you can see it's asking for the cost, the salvage value, the life, and then the period. So the period is what they're talking about there is which year are you in, because that actually matters in this one, meaning are you in the first year? Well, if you're in the first year, that's the largest slice of the pie, and then it gets smaller and smaller. So this one, again, is pretty simple. You're just going to take a smaller slice, therefore you're getting 100, 80, 60, 40, and 20. So it's actually incrementally going down perfectly by 20,000 in this example. Now let's take a look at this declining balance formula. Now this next one is a bit confusing, and I wanted to put it in here because of how confusing it was. So Excel tells us that they're calculating this by first taking the cost less the prior depreciation, DEPR, I'm just going to abbreviate it with, and then they multiply it by a rate that they come up with. And then they tell us that the rate that they come up with is equal to 1 minus the salvage divided by the cost, and then raised to 1 divided by the useful life in years, so the years. And to top it all off, they tell us that the rate is actually rounded to 3 decimal places. So let's go ahead and type this formula now, and I'm just going to start with the rate. So let's calculate that first. So let's say 1 minus the salvage value, which is 75,000, divided by the cost, 375,000. And we're going to raise that to, like we have here, 1 divided by the number of years of a useful life, which is 5. So I'm just going to reference all of these, close it up, and we get 0.28. And then remember I said that this number needs to be rounded to the 3rd decimal point. So I'm going to put in the round formula, and then this is the number right here that I'm calculating that's going to return a number with a big decimal. So then I'm going to actually specify that I want to only see 3 decimal places just by putting that 3 there, closing up and hitting enter. Now you see that's the same answer, 0.28, but let's go into the Format Cells dialog box with Control 1, and let's just increase the decimal places here. And you can see in this sample, 0.275, there's all zeros behind it. So now I know for sure that this is actually 0.275. So I'm going to hit cancel. I don't want all those decimals to be shown. And now let's go ahead and type the rest of this formula. So we're going to do the cost minus the prior depreciation. And since this is the first year of depreciation, we don't have any prior depreciation, so I'm just going to put 0. And then I'm going to multiply that against the rate that we calculated above. So we have 103, 125, and that's exactly what we calculated here in the DB formula. So the declining balance says that what's the cost, what's the salvage, what's the life, and what's the period. So this is how Excel is calculating this formula. I didn't want you to get confused with it when you're thinking of declining balance. Like over here we have a double declining balance, which is 200%. In accounting, you learn that there's also a declining balance at 150%. This calculation is completely different than I've ever seen in my history. So I just wanted to clarify what it is and how it works. So now let's go ahead and take a look at the double declining balance. And let's get rid of this here. And so with the double declining balance, this takes the rate, and it's going to be actually the rate is 1 divided by the years, and then it'll be multiplied by 2. So what that means is we're going to take 1 divided by the useful life, 5, which is going to be 20%, which is kind of like what we did in the straight line method, except for now we're going to actually multiply it by 2. And then the next thing is that we're going to take that rate, we're going to multiply it by the cost less the prior year's depreciation. One thing I want you to notice in this formula here is that the salvage value isn't included in it anywhere. And that's because it's actually automatically taken off at the end on the last year usually, or the last couple of years, and therefore it won't get depreciated. So in this example, we're just writing it out for the first year. That's why I don't have it included here. But in the DDB formula down here, you can see that salvage value is within the formula. So let's go ahead and write this formula. So the rate is going to be 1 divided by the years 5 and then multiply by 2. That's our rate of 40%. And then each year we're going to go ahead and take this rate and then multiply it against the cost less the prior year depreciation, which we have 0 here, and I'm going to close it up. You'll see that we get 150,000. It's exactly what the formula calculated down here. So double declining balance, DDB, open up the parentheses, and it's pretty simple. We're just going to take all of these things that we have, all these inputs above, and take the cost, the salvage, the life, and then the periods, and then a factor. This factor says 2, so what the 2 means is that it's double declining. We could change this to 1.5, and like I was saying in this previous DB one, you'll see this in accounting where you take 150% as an accelerated declining balance, but it's not a double declining, which would be 2. You could also change this to 3 or 4 or whatever you want. Just note that you're going to be depreciating a lot in the first year, and then it'll be tapering off as you go. So let's leave it at 2 and just hit enter. And you'll see 150,000 is returned. Each year thereafter, it's a little bit less and less. And then in year 5, it even comes down to 0. All right, so now let's just go ahead and take a look at this comparison table in a chart-like format. And I just noticed that I actually have these backwards, so this should actually be blue and this should be purple. Let me switch that real quick. Okay, that's now switched. Now take a look at these depreciation types in a chart-like format. You can see that this purple one, the DDB, double declining balance, it's the most expensive depreciation type we have here because it starts at $150,000 worth of depreciation expense in the first year and then tapers off. So it really depends on one of 2 things on what you're trying to achieve in your financials. So if you're trying to reduce your tax expense, go ahead and use a higher type of a depreciation for this year. But just note that the next year you're not going to be able to take that same amount of depreciation because it's much less. And then even by year 5 you have none left. But if you're looking to try to have your financials show a more realistic picture of how your company is doing, I would go ahead and use the straight line method just because it's most conservative and you get a decent amount of depreciation expense each year.